Welcome back, everybody. Today is part one of a two-part series in the normal distribution. There's an awful lot to do here, so I'm breaking this up into two parts. I'm going to focus the first part on the conceptual ideas about the normal distribution, as well as some of the skills that you'll need to be successful. Part two will be the more practical examples, taking the skills that we discuss in part one and putting them into practice in part two. So you really need both parts to be successful. I hope you enjoy. All right, let's get started. All right, so you remember we talked about the binomial distribution, right? And one of the drawbacks of the binomial distribution was that there was a limited number of trials. All right, and those limited number of trials creates a problem because what about a continuous random variable that can take on an infinite number of values? The more values that are in the distribution, the graph potentially becomes more bell-shaped. The mean, median, and mode all become the same. The total area under the curve becomes 1. If these three conditions are met, then we have what we call a normal distribution. So the first condition is graph is bell-shaped. The second is that the mean, median, and mode same. Total area under the curve equals 1. So what the graph might look like would be something like this. So the mean of the population or the mean of the sample would be right in the middle, and the most number of values would be in the middle, so the median and the mode would all be the same. The normal distribution can look slightly different based on what you're measuring. So for example, if I did a normal distribution for, let's say, the heights of women and men, all right, so I'm going to go, here's my continuum. So those are the heights of women. And let's say there are your heights of men. Right? Because men are just inherently a little bit taller. So for example, for women, your average might be, let's say, 63 inches with a standard deviation of 2.5 inches. For men, your mean might be 69 inches with a standard deviation of 2.8. Or something to that effect. So the bell could be taller, could be shorter, could be moved left, could be moved right. It's not always necessarily in the center. All right, so this is something that it makes, it makes it a little tough at times to compare two different normal distributions. Which is better? Is the mu of 63 better? Is a mu of 69 better? So we have to convert our normal distributions into a standard. All right, and we call that the standard normal distribution. And in the standard normal distribution, basically we're taking distributions, let's say, of different units, of different contexts, for example, men and women, and we're trying to push them into the same type of unit in order to compare them. So the standard normal distribution, again, would be still bell-shaped. The center would be in the center, and your mu would be 0. Your standard deviation would equal 1. All right, and the area, the total area, still equals 1. So the area to the left of 0 is 50%, right? Area is 50% of my area, so it equals 0.5. And the total to the right would equal not 0.05, just 0.5. This way, when you add up the two sides, you still get 1. There are a couple of different ways to find these different areas. And if we remember, during our study of continuous random variables, our area under the curve is equivalent of probability. So we're going to be very, very focused on getting the area under the curve, but it is going to relate to probability. So there are two ways to do it. The first is there's such a thing as called the empirical rule. The empirical rule is extremely useful because when the need arises, it takes a lot of the math out of it. So the amount of data contained within one standard deviation of our mean is 68%. All right, the amount of data contained within two standard deviations is 95%. And the amount of data contained within 3 standard deviations is 99.7%. If you're going beyond 3 standard deviations, if I'm going, let's say, 4 standard deviations positive, I'm going to get very much closer to my 100%. Never quite hit it, but you will get closer and closer. So let's create a graph and illustrate what I mean. Again, I'm hand drawing the graph, but this is always in the center, so mu equals 0. So 1 standard deviation plus or minus means I'm going to plus, right? So mu is always 0, so I'm just going to take the mu out. I'm just going to put a 0. That way we can illustrate this a little bit better. And here's -1. So the area contained within 1 standard deviation plus or minus is 68%. All right, now if I want to extend it to 2 standard deviations, I can add to my graph. That's a terrible 2. I can do better than that. There we go. That's much better. All right. So now that I have my 2 standard deviation set, all of that area, I'm going to change colors a little bit so we get a little contrast. All of this area now is 95% of our data. All right. And now I'm going to go back to blue. All right. I'm going to change color one more time. I'll change it to green. What the heck? All right. So within 3 standard deviations is going to be the green. And that's going to be 99.7% of our data. So almost all of our data is going to be contained within 3 standard deviations of our mean. So our mean is in the center. I say contained within that means plus or minus 1, plus or minus 2, or plus or minus 3. All right, let's go back to blue. I'm digging blue today. All right. So how do we convert to the standard normal distribution? Well, the way we convert is we use something called the z-score. And our z-score formula is z equals x, our data value, minus mu, all over our standard deviation. And this formula is going to help us map to our standard normal distribution. All right. So I'm going to do a fairly random example. So I'm going to say that if we have a distribution for the weight of dogs, let's say, and I didn't look up these numbers, I just kind of created the problem. So I do not know if these numbers are true. But let's say it is normally distributed. Let's say our mu is 69 and our standard deviation is, let's say, 2.8, and these are in pounds. All right, so let's say I want to convert this to a standard normal distribution. All right, so if I wanted to convert this to a standard normal distribution, I want to find a z-score. And let me give you a data value. Your data value will be 71.8 pounds. So how am I going to do that? I'm going to use my formula. I got z equals my x, which is 71.8, minus our mu, which is 69, all over 2.8. So when I do my subtraction, I get 2.8 divided by 2.8, which equals 1. So now when I redraw my graph, right, because when I redraw my graph in the standard normal, right, up here was 69. Now my mu is going to be 0, and my data value, I'm putting that a little far, put it a little closer, there we go. My data value, which is just going to be a little bit ahead of 0, is going to be a 1. And then I can compare it to other things. So for example, let's say my first dog was a golden retriever, and I want to compare it to a Shih Tzu, or I want to say, my golden retriever is 71.8 pounds. What's the probability, if I have a golden retriever, what's the probability that he is 71.8 pounds? I can then find that value. When it comes to probability, the good thing about our normal or even standard normal distribution is that someone has already calculated the probability for all of these z-scores for us. All right, so for example, if you have the z-score, the chart for the standard normal distribution that you were provided will tell you what the probability is. All right, the key is it tells you probability to the left. So let's use this current map. So for example, if I were to look up z equals 1, it would give me the area to the left of 1. All right. So why don't you, at this point, pause the video and get out your chart, and we'll look the first one up together. All right, hopefully by now you have your chart. You are going to look on the left side of your chart. You're going to see a column that's labeled Z, and you're going to go down that column until you find the number 1. 1.0 is what you'll find. And then you're going to go across until you find the appropriate hundredths place. So for example, in this particular one, my hundredths place would be 0, so 1.00, and you get a area of 0.8413. So if the context was dogs and I said, what's the probability I would find a golden retriever? 71.8 pounds. The probability would be 0.8413 or 84.13%. All right. So I want to focus a lot of our time on finding the different z-scores from our chart, because depending on the information you're given, or even how it's given, could affect your plan. So I'm going to give you some fairly similar problems in a variety of ways, and let's see how we do. All right, so our first example is find the area to the left of z equals 1.26. Very, very straightforward. A very good problem to start out with. All right, so we're going to go to our chart, and we're going to go to the 1.2 in our z column, and then we're going to go across to the right to 0.06, 2.06, and I get 0.8962. That is the area to the left of 1.26. So I'm going to quickly sketch this out. And basically what we just did was we found that area. Now remember, these areas are all rounded to 4 decimal places. Technically, if you were to do an integral every time you wanted to find an area, you potentially would have more decimal places, or So these are definitely rounded, but they're definitely useful to use, and they're definitely handy to have. All right, so let's change the problem up a little bit. And let's say I just said find the probability that our z-score was less than or equal to negative 0.3. All right, so this is the first time I'm seeing a negative z-score, so I just want to sketch this very quickly. Right, if 0 is right in the center and all of my positive z-scores have been to the right, negative 0.3 is going to be slightly to the left. All right, and if I'm looking for less than means that way. So I'm looking for, again, area to the left. So why don't you at this point pause the video, give it a try on your own, find the z-score, or find the area. All right, so if you look down the z column to negative 0.3, and then went across to the hundredths place of 0.00. The area I got area, or in this case, I probably would say the probability that z is less than or equal to negative 0.3 equals 0.3821. Once again, very, very straightforward, looking for area to the left. All right, so let's do another one. We're going to do an awful lot of examples right here, but this one, we're going to find the area to the right. to the right of z equals 0.6. All right, so again, I'm going to draw this out very quickly. I definitely recommend throughout the next couple of sections making these very, very quick graphs because they can be really helpful. All right, so there's 0, there is 0.6. So I'm a little to the right of my 0, and I'm looking for area to the right. So I'm looking for the area here. All right, now my chart gives area to the left. All right, so what's the plan going to be? Well, my total area equals 1, right? And so if I do 1 minus the area to the left, that's going to equal the area to the right. So why don't you pause the video, find that area to the left, and we'll talk about it on the back end. All right, hopefully you found that area to be 0.7257. All right, and that would be the area to the left. So that would be, I'm going to change colors very quickly. I'm going to change it to green. The green is what you just found. The trouble is, I asked you for the blue area. So we'll change back to blue because I'm enjoying writing with blue. And I'm going to do 1 minus that area, and that winds up equaling 0.2743, which would be our area to the right. All right. So I'm going to change the information again, and let's see how we do. All right, so what if I just said find probability that z is greater than 1.28? So now I'm asking about probability, but it's still area under the curve. Remember, area under the curve is your probability. So like I said, I always make a graph. This way I can figure out if my answers are reasonable or not. The one big thing where you're going to make a mistake here is if you're looking across the chart and you go one column short or you go one column down, you don't, go in a straight line. So just be very careful with that. I would definitely bring a straight edge, use a straight edge to make sure that you get across to the correct number. All right, so if my z is negative 1.28, that's going to be back here. And my chart is going to give me the blue area, the area to the left. Now my question asked the green area. I wanted the area to the right because I said greater. So what are we going to do? Well, we're going to look up the area of negative 1.28. That's my area to the left. And the plan is going to be 1 minus area left gives me area right. So I'm going to be 1 minus, and I got an area of 0.1003. Why don't you pause the video, do the subtraction, and I'll give you the answer on the back end. I got 0.8997 as my area, which does make a lot of sense because I moved over pretty well. So I definitely would have an area greater than 1/2. All right. So now that we found area to the left and we found area to the right, maybe it's time to find an area in between. So my next example asks you to find the area between z equals negative 0.6 and z equals 1.23. All right, let's try that one. Try one together, and I'll let you try one on your own. At this point, you should be pretty good at looking up these numbers. All right, so when we look up our area for 1.23, use a highlighter for this because we're going to have a few different things. I'm going to get the yellow highlighted section, yes? All right, so my area for to the left of z equals 1.23 is 0.8907. All right, then I want to look up negative 0.6. With negative 0.6, I'm going to find the area of the green section. All right, and when I look that up, go back to blue, I like blue. So area z equals negative 0.6. I got 0.2743. Now what the question is asking me is I want the area in the middle. So really what I want is I want the blue highlighted area. So the way I can do that is if I take the yellow area and I subtract off the green area, I wind up with the blue highlighted area. So let's go back to blue. I like writing in blue. So I take 0.8907 and I subtract that from 0.2743 and I get 0.6164. All right, so you guys are now becoming an expert in these areas. So I'm going to just change the presentation of the information and say find the probability 1 less than z less than or equal to 2.83 and ask you to pause the video, do the problem, and I'm going to share the answer with you on the back end. All right, hopefully you have done everything you need to get an answer. I'm going to be a little bit quicker, only because by now you guys are experts in this. There's 0, there's 2.83, there's 1. So I'm going to look up my area of 2.83. I'm going to subtract the area to the left of 1. What the area that's left should be the area in between those two values. So if I looked up 2.83, I got 0.9977. I'm going to subtract that from my area of 1 to the left of 1. So I get 0.8413. And I got what's left is 0.1564. And that is my area in between those two values. All right, so the last thing I'm going to leave you with is what if we needed to go backwards? What if I told you that I knew the area, but I needed to know the z-score? So if I said, like, example, find the z-score for, and I'm going to give you a graph. I'm going to say that the area in between is 0.4177. And I would like to know what z equals. All right. So things I know. I know the area to the left of 0. Is 0.5. And I know that the area in between 0 and z is 0.4177. What if I subtracted those two? What would the area be that I got left? So if I took my 0.5, which would be everything, right? And then I subtracted off the green part, just the green part, I would be left with the area to the left of z. So let's try that and see how it works. All right. So if I do 0.5 and I subtract 0.4175, I wind up with 0.0825. Now we can still use this chart. Instead of going to the outer column, the z column, what I want to do is I want to look in the belly of the chart where we were finding those areas, and I want to look for 0.0825. All right, so when I look for that area, and it's going to be less than 0, all right, so you can start by looking in the negative values, all right, and then once I find it, I want to go out to the left to the z column, and I find I get negative 1.3, and then I want to go to straight up for my hundredth place. I see that that's a 9, so this is my z that I'm looking for, and there is my answer. All right, so let's try one more. I'll change the information on you a little bit. This will be our last example of the day. I'll say find yes, that's not score at all. Find the z-score for, I'm going to give you the graph. There's 0. There's my z. And I'm going to say the area to the right is 0.239. All right. So for this one, I have the area to the right of my z. But in order to use my chart, I need area to the left. So what am I going to do? I'm going to do 1 minus my area to the right. And that should give me my area to the left. By my count, I got 0.9761. Once again, I do the exact same thing. I know my z is going to be positive, so I'm looking in the positive values only, right? Because I'm to the right of 0. And I'm going to look for 0.9761 in the middle of the chart. Might take a minute, so look for it in the middle of the chart. Once you find it, go all the way over to the left, to that z column. And I found that z is going to be 1.9. And then I go up to my hundredths place. When I go up to my hundredths place, I got 8. So that is what my z equals. There are plenty more problems we can do for these skills. I'll have a few more in the follow-up. Hope you enjoyed. I will see you in class.